Good morning, everyone, and welcome to this special lecture. We are dealing with circular motion, and this lecture we will try to wind this topic up, see what all things can come in the exam, and how we can tackle them. Circular dynamics. In the previous class, I think we had seen the relationship between angular and linear quantities. We had seen that. Distance traveled by the particle is r multiplied by the this angular displacement. Yes or no?
Yes, sir.
We had seen that this velocity with which it is moving, you can also call it tangential velocity because it is always tangent to the path, and this tangential velocity is omega multiplied by r. Then there is this tangential acceleration, which is alpha cross r. This alpha is the angular acceleration, and this tangential acceleration, it changes the magnitude of tangential velocity. If tangential acceleration is 0, then your angular velocity, then your alpha will be 0, your angular velocity would be constant, and we call that motion as uniform circular motion. But whether it's uniform circular motion or whether it is non-uniform circular motion, it always has an acceleration, and that acceleration is known as which one?
Centripetal force. Centripetal acceleration.
That acceleration is known as centripetal or radial or normal acceleration, and this centripetal or radial or normal acceleration can be written as omega cross v. I told you it's an axial vector. You can write it magnitude wise as omega into v or v square by r, omega square into r. It changes the direction of velocity. Tangential acceleration changes the magnitude of velocity. They both together become your net or total acceleration. Everyone understands this, yes?
Yes, sir.
Okay. So let us start with some questions on this. Let me first give you questions. Let me first start with questions on this. We'll again concentrate on questions that are more likely to come. And this is the first type of question. Which is on your screen now. The speed of a particle traveling in a circle of radius, speed of the particle traveling in a circle of radius 20 centimeters increases from 6 meter per second to 8 meter per second in 4 seconds. Find out its angular acceleration. I'll give you 2 minutes to solve this. Just do we have anything that looks like an answer?
Yes, sir.
What is that?
2.5 radian per second square.
2.5 radians. Let me check. Just looking at something else. Okay, so I have the answer with me. 2.5 radians per second square. That is correct. So how do you get it? See, the magnitude of velocity is changing. The magnitude of velocity is changing. The magnitude of speed, the magnitude of tangential velocity is changing. That means it has tangential acceleration. Yes or no? So how
Yes,
much is the tangential acceleration? Final magnitude minus initial. So 8 minus 6 divided by not 20 but zero point 0.2. No, sorry. Divided by 4. 4 seconds it changes, right? So this becomes 0.5 meter per second square. That is your tangential acceleration. Once you know your tangential acceleration, you can calculate the value of alpha. At by the radius 0.5 divided by 0.2 and you get your answer. Do we understand this? Yes or no?
yes, sir.
Okay, simple question. To understand the concept, this is how you understand the concept, and let us do the next one. The more the number of questions that you do, I've already sent you the sheet. The sheet of 1D motion will have 1D and 2D motion will have this circular motion also. Anyways, whatever questions are there, I will solve it in the class only, so you don't have to do it. Question number 2. A particle is moving in a circular radius 10 centimeters with uniform speed. Now, whenever we say the speed is uniform, what type of motion it becomes? In a circle with uniform speed, what type of motion does it become? Moving in a circle with uniform speed, what type of motion it becomes?
Uniform circular motions.
Right, uniform circular motion. Okay, so this is uniform circular motion. Uniform speed completing the circle in 4 seconds. Find the magnitude of its acceleration. They have only asked you acceleration, but I can ask you other things as well. I can ask you is omega. I can ask you is speed. I can ask you is frequency. I can ask you is time period. So one question, I can ask 5 or 6 different questions, solve them so that you understand the concept of uniform circular motion as well. Do we understand this? 2 minutes you will have to do this one. Yes, do we have the answers? Here. Hmm. No one has answer. Shall I do it?
Sir, 1 minute.
Okay. Shall I do it?
Sir, omega is 1.57 radians per second square. Sorry, second per second. V
First, tell me what is the time period.
4, sir.
4 seconds. Start from here. What is the frequency?
Frequency is 1/4.
1 by 4 hertz. Correct. What is omega?
It is pi/2 or 1.57.
Pi by 2 is okay. Pi by 2 is okay.
Pi/2. Okay, sir.
Okay. What is the speed?
Pi/20, sir.
It will be in centimeter per second then.
Centimeter per second means
10.
I have converted it into meter per second.
Okay. 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 So what is the speed?
Pi/20 meter per second. It is coming, sir.
Pi by
20 meter per second.
pi by 20 meter per second. So basically you multiply omega by r, and r is 10 centimeters is 10 by 100, right?
Yes, sir.
Okay. Okay. Then you can find out its tangential acceleration. It is moving with uniform speed, so tangential acceleration is 0. Then you can find out its centripetal or normal acceleration. How much is that?
Pi square by 40, sir.
Pi square. So it is omega square into r. So omega square is pi square by 4 into r is 10 by 100. Do we understand this?
Yes, sir. Pi square by 40.
Pi square by 40. Now, if I ask about its total acceleration, since its tangential acceleration is 0, its total acceleration be pi square by 40. Normal acceleration and total acceleration are same. Do we understand this?
Yes, sir.
Everyone in the class? Okay. Now, there are only 3 or 4 problems of this type. So, this is the next one. This is a very common problem. You will find this problem in many books. This problem has come in exams as well. So let us see if you can give me this problem. A particle moves in a circle of radius 2 centimeter at a speed given by remember, speed given by v is equal to 4t, where t is in centimeters per second. You can give your answer in centimeters per second. Don't need to convert it, because I also have the answer in centimeter per second, where v is in centimeter per second and t is in seconds. Find the tangential acceleration, find the total acceleration at 1 second. Give you 2 minutes to do this. Will you able to do will you be able to do it, or you need help?
ఆన్సర్ వచ్చిందా ఇంకా ఇంకా ఎయిట్ ఈస్ ఫోర్ చెప్పు
Shall I do it?
Sir, tangential acceleration is 4. Total acceleration is 4 root 5.
Wow. Good. Well done.
Thank you, sir.
Good. Very good. Okay, so how are we supposed to do this? Remember, this is, and what I wanted to make you know, this is speed. Speed is given. Now, there's only one acceleration that can change your speed. And what is that acceleration that can change your speed? That is your tangential acceleration. So you can also call tangential acceleration as, and you can write it, it is rate of change of speed. It changes your speed. It changes your magnitude of velocity. So now you can find the derivative of this, d of v. I will not call it as v, I will call it as s, so that you understand that this is speed. Do we understand this?
yes
ds by dt. ds by dt will be equal to 4. That implies your tangential acceleration is 4. It is constant because it does not depend on time. Now, we found out the tangential acceleration, but we still need to find out the normal acceleration. The normal acceleration or the centripetal acceleration will be given by v square by r. Now, v square at 1 second, the value of v is 4. So v square becomes 16 divided by radius is 2 centimeters. So it is 2 multiplied by 10. Yes or no?
yes sir
So you get your, or you can just keep it in, you can just keep it in centimeters. So the calculation becomes simple. So it becomes 8 centimeter per second square. This is 4 centimeter per second square. Now you have to find out the total acceleration. Bacha, total acceleration is 80 square plus an square. You can square them, add them together, and we get the answer. Do we understand this?
yes sir
Chalo, then let me put you this question. To understand this question, well, let us see. This is the question. A particle begins to move with a tangential acceleration. So initial angular velocity is 0. Tangential acceleration is constant 0.6 meter per second square in a circular path. If it slips when its total acceleration becomes 1 meter per second square, find the angle through which it would have turned before it starts to slip. It's a simple question asked in a different way. You have 2 minutes to give me the answer. Just bacha, can I help you or you can do it alone? If you do it on your own, you will get confidence, which you cannot get if I do it. Yes.
Tell me, sir.
Okay. It is simple. Starts to move, so its initial angular velocity is 0. Tangential acceleration is given. Total acceleration is given. So, total acceleration A is under root of AT square plus AN square. Yes or no?
Yes, sir.
Now, you have to find out the angle through which it has turned. I think the radius of the circle is not given, no?
Yes, sir.
The radius of the circle is not given, so let us take it as 1. Because without the radius of the circle, we will not be able to calculate this. So let us take the radius of the circle as 1 meter. I think that is the missing information in the question. Okay. So 1 is equal to under root of tangential acceleration square is 0.6 square plus an square. From here you will get the value of an or normal. Yes or no?
Yes.
So you will get a normal as 1 minus 0.36 ka root. Yes or no?
Yes, sir.
So that will come as I think 0.8. Yes or no?
Yes, sir.
Meter per second square. Now that is equal to omega square multiplied omega square multiplied by r. Yes or no?
Yes, sir.
So from there you can get the value of omega square. Omega square will be equal to 0.8 radian square plus second square. Yes or no?
Yes, sir.
Now you can apply those equation number 1, equation number 2, equation number 3. Omega 2 square will be equal to omega 1 square plus 2 times alpha into delta theta. Yes or no?
Yes, sir.
Now here omega 1 square is 0 and omega 2 square is 0.8. That should be equal to 2 into alpha. How much is alpha? Your tangential acceleration is given as 0.6. If you divide it by the radius, you will get alpha. Yes or no?
Yes, sir.
So your alpha will be 0.6. Radius was missing in the question. So 2 multiplied by 0.6 multiplied by the angular displacement. From here, you can get the angular displacement, bacha, as 0.8 divided by 1.2. The only thing that was missing was the radius of the circle was not given. And the radius of the circle, if we take it as 1 meter, we will get these answers. Do we understand this?
Yes, sir.
Okay, have you done this?
No,
I'll give
sir.
you 1 minute to note this down. We understand this now?
Yes, sir.
Okay. Now, Before going any further, you can just take this as a note. Uh, Sometimes what happens is you are given a question of uniform circular motion and you are asked what is the magnitude of change in velocity. So you can just take this as an important note and just note it down. So whenever this question comes, you don't have to calculate it. Remember, uh, time is a luxury that we don't have, right? So you can write it as a heading, you can write it as an important point. Magnitude of change in velocity. Magnitude of change in velocity. Now, what do you see here is you see two instances. In the beginning, the body is at A, then the body is at B. At A, the velocity is VA, tangential, and at point B, velocity is VB. Now, sometimes they are going to ask you what is the magnitude of change in velocity. So, change in velocity is delta V vector, and they ask you its magnitude. So, basically, what you need to do here is you need to find out VB minus VA and find out its magnitude. This is nothing but the vector addition of VB with the negative of vector A or the subtraction of vector A from vector B. You can straight away use the formula of addition or subtraction of two vectors and you can get your answer like this. It will be VB ka magnitude square plus VA ka magnitude square plus 2 times VA VB into cos of 180 minus theta, because the angle will become 180 minus theta. Cos of 180 minus theta is minus cos theta, so your final answer will look like this: VB square plus VA square plus 2 times, oh sorry, instead of plus you will have minus 2 times VA VB cos theta. So this is the general formula of magnitude of change in velocity. Do we understand this, or this has gone above our head saying bye bye? Bye bye, I'm going, don't worry about me. Magnitude of change in velocity. See, all these things, if you are going to do in the examination hall, you are going to lose a lot of time, and that is not allowed. You cannot lose time in the examination hall. Now, you can do a special case if the magnitude of VA is equal to magnitude of VB, which is equal to V. So I am talking about a motion where the magnitude of velocity does not change or it is moving with uniform speed. That means I am talking about UCM. Do we understand this?
Yes, sir.
If we talk about UCM, then the formula becomes V square plus V square minus 2V square cos theta. V square can be taken out. It will be 1 minus 2 times cos square theta, and then it can be written as sine square theta. Root of sine square theta will become sine theta, and you can write it in terms of half of the angle. Do we understand this?
Yes, sir.
2 times V square cos theta. 1 minus 2 cos theta will be 2 times sine square theta by 2. 1 2 will come out, and your net answer would look like this. The magnitude of change in velocity will become, and it's a very important result, 2 times V sine of theta by 2. I have seen some very direct question coming from this topic, and that is why I am giving you this thing. Formula number 1 is the general formula. Formula number 2 is the special formula, which is valid when your motion is UCM. Well, do you understand this? Why are people missing? The two people are missing. Why have they gone?
People miss cycle. They didn't had breakfast morning, sir.
Okay. Why you don't have breakfast in the morning? You stay in the hostel, no?
Breakfast completed in hostel, so they went now. Sir.
Okay. Chalo. I'll give you 2 minutes to note it down. Once you are done, please let me know.
Done, sir.
Okay. Now, since we have done this, we can move ahead and let me again introduce a concept of relative motion in angular velocity. So you can write it as relative angular velocity. Now remember, whenever we talked about this angular velocity was with respect to an observer which is stationary on Earth. Now, I told you rest and motion are all relative terms. It all depends on your reference frame. Do we understand this? Sometimes we might calculate this relative velocity, this angular velocity, not with respect to one point, but with respect to some other point. Sometimes we may not calculate it with respect to one body, we might be calculating it with some other body. Do we understand this?
Yes, sir.
So, whatever we are doing is actually relative angular velocity, but it was with respect to one fixed point. We can find out this angular velocity with respect to other points as well. Do we understand this?
Yes.
So if I take the simplest example of this, and this has come as a question in previous exam, so you can draw this. They ask you this question like this. I'll put the diagram so that I'm able to make sense of out of this. See, they will give you a body which is moving in a circular path. The center of the circle, let us say, is point O, and they might tell you that it is moving with an angular velocity omega with respect to the center O. And then they might ask you what would be the angular velocity of this particle with respect to any point on the diameter of this line which is drawn parallel to this. How will you find out? How will you find out the relative velocity with respect to omega A? If I call this omega naught or omega 0, what will be the relation between omega 0 and omega A? I'll give you 1 minute, 2 minutes to think about it. This is the question, but then I will give it as a note so that you are not caught in this question. I'll give you 2 minutes to think about it. If you can think and get me the answer, well done. If you can't, I'll give you the note. I'll tell you also how to do it. 2 minutes.
Sir,
Yes, sir.
sir, it's omega A cos beta minus omega naught cos alpha.
How did you get it?
Sir, I have resolved them along the.
You have resolved angular velocity along something.
No, sir. We resolved along the reference line, sir.
So your omega naught is d alpha by dt, rate of change of alpha with time. We understand this alpha is the angle. Yes or no?
Yes, sir.
Your omega A will be d of beta by dt. Yes or no?
Yes, sir.
That's your answer. What is the relation between alpha and beta? Huh? This is 9th, 7th, 8th standard maths.
Wait. Triangles resolve this polygon. 180 minus alpha.
Array exterior angle.
Exterior angle.
Do we understand this?
Yes, sir.
Alpha is 2 times beta. Yes or no?
Yes, sir.
So omega naught is 2 times of omega A. Do we understand this? Huh?
Yes, sir.
Ah. Note this down.
For relative angular velocity.
Have you noted it down? Yes, sir or no, sir?
Yes, sir.
Kindly move ahead, sir.
Okay, sir.
Then sometimes we might be asked some difficult question. They might ask you the relative angular velocity of one particle which is moving in circular path with respect to another particle which is also moving in a circular path, or in general they might be moving in different directions. They might ask you the relative velocity of any particle A with respect to any particle B. So what we need to calculate here, we have to calculate is the rate at which The vector of A is moving with respect to B. Do we understand this? Yes or no?
Yes, sir.
Now, if you want to write it as a formula, so it will look like this. And remember this, and we might solve some questions based on this so that you understand this concept. So the relative angular velocity of A with respect to B will be the component of relative velocity of A with respect to B perpendicular to the line joining A and B. Don't worry, I'll show you the diagram as well. Divided by the separation between A and B. Divided by the separation between A and B. Now, how do we understand this? Have you noted this down? Huh?
1 minute, sir. Sir, what is your perpendicular line, sir? Perpendicular to the line.
Have you written it?
Yes, sir.
Everything written? Done? You've written it? Yes or no?
Yes, sir.
Then this question. Find the omega of A with respect to B. A is moving, as you can see here, with a velocity V. A. B is moving here with a velocity VB. The distance between the two is given as R. So what are given to you? VA is given to you, VB is given to you, R is given to you, theta 1 is given to you, theta 2 is given to you. You know the definition. Angular velocity of A with respect to B is velocity of A with respect to B in a direction which is perpendicular to the line joining them divided by the perpendicular distance between A and B. Now, I'll give you 2 minutes to find this out and tell me the answer. Else, obviously, I'll tell you and you will keep it as a note. Yes, shall I help you? Now, anyone got any answer?
Sir, VA sin theta 1 plus VB sin theta 2 by R.
See, you understood it. That is it. I said, give some time. So basically what you got to do is we need to resolve this into two components. So this component will be VA sin theta 1 and this component will be VA sin theta 2. Similarly, we need to resolve this velocity into two components. This will be VB cos theta 2 and this would be VB sin theta 2. You all understand this?
Sir, here VA sin theta 1, theta 2, both one.
What? What happened? Any problem? Did I do anything wrong? You understood this? Yes or no?
Sir, for A, you have resolved 2 as 2 different something.
I've written it wrongly. That is what you are saying? VA cos theta 1. Okay?
Yes, sir.
Okay. Now remember what is happening. When I find the angular velocity of A with respect to B, remember it is same as when I found out the velocity of A with respect to B. When I find out the angular velocity of A with respect to B, remember that this point B does not go anywhere. So I become B. Now I become B and I look at A. Now remember, this is not motion in one dimension. This is motion in relative motion in two dimension. So now how I'm looking at A is how I'm seeing A. Now A, when I become B, A is moving like this. Now, if I think in terms of circular motion, how does it look like? So when I become B, there is one component of velocity of A which is going away from me, and there is one component of velocity of A which is perpendicular to me. Yes or no? This
Yes.
is the velocity of A which is perpendicular to me. Because of this velocity, he will look like that he is moving in a circular path around me. Do we understand this?
Yes, sir.
And because of this component of velocity, he will either go away from me, velocity of separation, or he will come
Closer.
towards me, velocity of approach. Do we understand this?
Yes, sir.
But since I have become B, everything has to be calculated with respect to me. Yes or no?
Yes, sir.
So now I just write it and I get my answer. Velocity of A with respect to B in a direction which is perpendicular to R. So it will be this velocity. If I take this as positive, this will become negative. Yes or no?
Yes, sir.
So this minus this. So actually it becomes plus. So it becomes VA
Sin theta 1
plus
plus VB.
VB sin theta 2. Do we understand this?
Yes, sir.
Yes or no? Then I can also find velocity of A with respect to B in a direction which is parallel to AB. So it will become VA cos theta 1 minus VB cos theta 2. Do we understand this?
Yes, sir.
So this will be your velocity of separation or velocity of approach depending on who is bigger and who is more. If VA cos theta 1 is bigger, it is velocity of separation. If VB cos theta 2 is bigger, it is velocity of approach. Do we understand this?
Yes, sir.
So now I can find the angular velocity. Angular velocity of A with respect to B is simply VAB. So that is VA sin theta 1 plus VB sine theta 2 divided by the perpendicular distance r. Now, if it is given that VB cos theta 2 is more than VB cos theta 1, VA cos theta 1, then you can find out after how much time they will meet. After how much time they will meet? Can you tell me what is the time of meeting? If they move with constant velocity, what will be the time of meeting? When will they meet? They will only meet when VB cos theta 2 is more than VA cos theta 1, because then the distance will decrease. When will they meet? Huh? When will they meet? And they will meet at VB cos theta 2. Sorry. R is the distance between them divided by VB cos theta 2 minus VA cos theta 1. Do we understand this?
Yes, sir.
It becomes a simple case of B catching A or A catching B. Don't have to look for the perpendicular component. We have to just look for the catching component. I hope this has made sense. Yes or no? No, yes?
Yes,
Ah?
sir.
Do we understand this?
Yes, sir.
Then this question. There are two particles which are all moving on a circular path. A is moving with VA. Radius of circle A is RA. B is moving with VB. Radius of circle of B is RB. You have to find the angular velocity of A with respect to B. And it is very simple.
Sir, it is VA minus VB by R.
It is VA minus VB divided by R. Do we understand this? Where R is the distance between the two, RB minus RA. Do we understand this?
Yes, sir.
Okay. Now, using this concept of relative velocity, if two bodies are moving on the same circular path, you can also find when they are going to catch each other up. Yes or no?
Yes, sir.
So just you can take it as a note, and remember this is say, for example, these are the two bodies that are moving in the same circular orbit. same radius. B is rotating with an angular velocity of omega b, and A is moving with a velocity of omega a. Now, if omega a is more than omega b, A is going to catch B, yes or no?
Yes, sir.
Now, here, if you find the angular velocity of A with respect to B, that will give you the how the angle between from A to B changes. We don't want to know that, right? Here we have to find the rate of change of angle, this angle theta. So the rate of change of this angle theta. You understand the meaning? The angle with the center, not the angle between A and B, the angle with the center that A and B makes. Do you understand this?
Yes, sir.
That is nothing but the rate at which angle B is changing minus the rate at which angle A is changing. You understand the meaning of angle B? Angle B is the angle that B makes with initial line. A is the angle that A makes with the initial line. Do we understand this, bacha, what I'm saying?
Yes, sir.
This is angle A and this is angle B. So now you can write it as omega B minus omega A. Remember, this is not the angular velocity of B with respect to A. This is the rate at which the angle at the center between A and B changes. Do you understand this?
Yes, sir.
Then they ask you the time taken. Time taken for B to complete one circle. With respect to A. That means they can put the question like this. At 0 seconds, B has overtaken A. After how much time it will again overtake A? Because they are moving in a circular path. Do you understand this?
Yes, sir.
So they can ask you after how much time will it again overtake A? So how do you find out that time in which it can again overtake A? You can simply write that time as 2 pi because it has to move an angle of 2 pi divided by omega B minus omega A. Do we understand this? Yes or no? No or yes? Do we understand this? Okay. I give you a question. This question has come in one of the JEEs. Two questions are there, I think. Have you noted this down?
Yes, sir.
This is the question that we are looking at. Two particles A and B move on a circle. Initially, particle A and B are diagonally opposite to each other. Particle A moves with angular velocity pi radians per second, angular acceleration pi by 2. Particle B moves with constant angular velocity of 2 pi radians per second. Find the time after which both the particles A and B collide. They are moving in the same sense. Do we understand this?
Yes, sir.
If you want, I can show you the diagram. Do you want me to show you a diagram?
No, sir.
Then do it. Both are moving in the anti-clockwise sense. Shall I do it? It is such a simple problem. It is not such a difficult one.
Yes, sir.
You're not able to do it? Why it is so difficult? It is a simple problem. This is the diagram. You become body A. And you can find out. Now, this is the same question as what we had done here. This one. When will they catch each other? Do we understand this?
Yes, sir.
So, I can find out the rate at which this angle is changing with respect to A. So, let me write this d theta by dt, which actually becomes sort of its angular velocity of B with respect to A, though it is not exactly that, but you can just treat it like this to understand. Now, this is also anti-clockwise. This is also anti-clockwise. So it is 2 pi minus pi. So it will be pi radians. Yes or no? Pi radians per second. We got this.
Yes, sir.
Then we can find the relative angular acceleration. This angle, when it changes, what is the rate of change? So you can find it out as alpha b minus alpha a. Do we understand this?
Yes, sir.
So that will become, because alpha b is 0, it will become minus pi by 2 rads per sec square. Yes or no?
Yes, sir.
What is the total angular displacement of b with respect to a? B with respect to a should move like this. Yes or no?
Yes, sir.
This is also clockwise. This is also anti-clockwise. Yes or no?
Yes, sir.
Total angle is plus pi. That must be equal to omega into t. Omega into t plus half into alpha, which is minus pi by 2 into t square. Pi will cancel. This is a simple quadratic equation in t. The equation will look like this: t square minus 4t plus 4 is equal to 0, or t is equal to 2 seconds. Do we understand this? How it is done? This is the same question as one body moving like this, one body coming from piche. When will this piche wala body overtake the other body? The only thing is, it is in terms of circular motion. A is the aage wala body, the body in front. B is the body which is behind. A is moving with a velocity and acceleration, but B is moving with a constant velocity. When will B overtake A? That's it, my dear friends. Do we understand this, or this has gone above our head saying bye bye? I'm going bye bye, bye bye. Do we understand this? Where were you making a mistake? Can you tell me what was the point that you could not understand? Yes. Huh? Which point you could not understand? Have you noted it down? Shall you move ahead?
Yes, sir.
Have you understood this? I understand that this probably was a tough question, but don't expect such questions in JEE Mains. This was question for JEE Advanced. Do we understand this?
Yes, sir.
You can just write important notes. We have talked about three types of acceleration: normal, tangential, and total acceleration. You can just note them out down as points, which we have already discussed. Point number 1: if normal acceleration is 0, if normal acceleration is 0, body only has tangential acceleration, the total acceleration becomes equal to your tangential acceleration, and this motion is motion in a straight line. Do we understand this? This is your straight line motion. Do we understand this? If your tangential acceleration is 0, if your tangential acceleration is 0, your magnitude of normal acceleration is constant. Magnitude is constant, but it will keep on changing its direction. Remember, then this will represent a case where omega will be constant. Omega will be constant, and this will be the case of UCM. Do we understand this? Why I am not saying the normal acceleration is constant? Because normal acceleration also keeps on changing its direction. So I cannot call the normal acceleration as constant. I can only call the magnitude of normal acceleration as constant. Do you understand this?
Yes, sir.
If in all the other cases, it will become any type of motion that you can talk about. It can become non-uniform circular motion. It can become motion on a curved path, curvilinear path, whatever. These two are special cases. If you remember these two special cases, these are the cases that we have done so far. Have we noted this down?
Yes, sir.
Then we move on to the next part, which is dynamics of circular motion, or circular dynamics, we call it. Now, as soon as I use the term dynamic, this term dynamic means we will talk about what causes this acceleration. And what causes acceleration? What causes acceleration? Huh? What causes acceleration? Force causes acceleration. So whenever we come into dynamics, we talk about force. We have talked about two types of acceleration. Therefore, there are two types of force. Number one is tangential force. Tangential force. You can call that force as Ft. How will you get the value of this tangential force? This Ft will be nothing but equal to m into At. Do we understand this?
Yes, sir.
And this is exactly same as what we were doing in Newton laws of motion. So this will be net force. Net force in which direction? This will be equal to the net force in the tangential direction. Do we understand this? So to find the tangential force, you just find the net force in the tangential direction. That will be equal to m into At. Do we understand this?
Yes, sir.
Huh?
Yes, sir.
Remember in Newton laws, we were writing one force is in this direction, F, friction is in this direction. So the net force is F minus F. That net force F minus F was in the direction of motion, in the direction of velocity. That was your tangential force. Do we understand this?
Yes, sir.
Then what is the second type of force? Tell me. One is tangential force, one is
Normal force.
normal force or centripetal force or radial force. You call it centripetal, you can call it normal, you can call it whatever, radial. How will you? So this centripetal or normal force Fn will be equal to m into An. Yes or no? So you can write it as m into omega cross r, but this is not the way it is normally written. If we just use the scalar formula, just talk about the magnitude, you can write it as m into An that will be equal to m omega square r or mv square by r. Do we understand this? We normally talk about the magnitude. The direction of this force is towards the center, so we'll write it as net force in the radial direction, or it will be the net force towards the center. Do we understand this? So you will resolve all forces, whatever the force is towards the center, that will become the net force in the radial or centripetal direction will become your centripetal force, and this centripetal force will give you centripetal acceleration. Do we understand this?
Yes, sir.
Now, whenever we talk about this circular dynamics, we will break it up into two types of circular motion. One is a circular motion taking place on the horizontal plane. If this is where you are sitting, this is the horizontal plane. So circular motion taking place here. That means any motion taking place on a flat road is a circular motion in horizontal plane. Do we understand this? Any motion that is taking place on your table is a circular motion taking place on your table is horizontal circular motion. Any motion that is taking place on the plane of your board is vertical circular motion. Do we understand this?
Yes, sir.
So first of all, we will start with horizontal circular motion or circular motion in a horizontal plane. So write the heading CM in, not CM, Chief Minister, not Chief Minister. It is circular motion in horizontal plane. Now, before moving on to any question, whether it's a question on horizontal plane or whether it's a question on vertical plane. Now, when you talk about horizontal plane, this is the horizontal plane. Now, up till now, we were always deciding your three directions by your three axes, X, Y, and Z. Yes or no? X,
Yes,
Y, and Z. These were your three axes. These were your three directions. Yes or no? Right?
yes, sir.
But we must understand that in circular motion, X, Y, and Z may not be the way to go about. So whenever we talk about circular motion, how do we give the direction? We talk about the plane in which circular motion is happening. So that is the plane. So it has two directions, and then there is a direction which is perpendicular to the plane. Do we understand this?
Yes, sir.
Now in the plane, how do you give the two direction? So one direction is towards the center of the circle,
Okay,
radial direction, and the other direction is which one?
tangential.
Tangential. So this is how we define three directions for a circular motion. Tangential. This is
Towards center.
towards center, centripetal or radial, and this is perpendicular to the plane. Do we understand this, or this has gone above our saying bye bye?
Yes, sir. We understood, sir.
Okay. So we will make equation along three direction. We'll not require this because we'll not be having three unknowns. We'll be only having two unknowns. So out of this, we might have to make only two equations. The first equation will always be along. To solve this, the first equation will always be along which direction? Towards what? Towards the center. And how will you make? You will find the net force towards the center. Remember, towards the center. net force towards the center. That will become your Fn or F centripetal, and you will write it as m v square by r, or m omega square r, or you can write it as m into an. Do we understand this?
Yes, sir.
Then you will make the second equation. And where will be the second equation?
Tangential.
Tangential direction. Then again you will find the net force. That will be your Ft. That will be your m into tangential acceleration. Third equation if required. Where will you make? In a direction perpendicular to circular motion. Do we understand this?
Yes, sir.
And in this direction, nothing will happen because circular motion is happening here. So in this direction, nothing will happen. So net force in this direction will always be equal to 0. Do we understand this?
Yes, sir.
These are the three directions along which you have to make equations. And now you know how to make equations. You should be able to do it. Get your answers and stay happy. Okay?
Yes, sir.
Okay. Let me see if you can solve some problems based on this. Simple cases. Can I trust you on this?
Yes, sir.
If you can do the first question, that means you have understood the concept. This comes. Question number 1. A block of mass 2 kg is tied to a string of length 2 meter. The other end of the string is fixed. The block is moved on a horizontal plane with a constant speed of 5 meter per second. Find the tension in the string. Let's see who can get me the answer.
Sir, it's 25 newtons.
Sir, is 25 newtons. How did you get straight away?
It's centripetal force, sir.
Now here in this case, the centripetal force is given by what?
Tension.
Tension in the string. So if you just look at the diagram, and I shall show you the diagram to get an understanding of what is happening here. Remember, this is a horizontal plane, so motion is taking place on your table. So you can understand it in terms of your table, and you are looking from the top. So this is the top view. Do we understand this?
Yes, sir.
So now here you can make equation along 3 directions. Tell me what are those 3 directions. The first is towards the center like this, yes or no?
Yes, sir.
The second one is perpendicular, which could be in this direction or in this. The second one is tangential, which could be in this direction or this direction. Yes or no?
Yes, sir.
And the third one is outside of the board. Yes or no?
Yes, sir.
Coming out of the table. Do we understand this?
Yes, sir.
Now there is no force in the tangential direction because it is moving with constant speed. So
Constant.
this and this They will cancel out. No problem. Yes or no?
Yes, sir.
Now you can make equation along the centripetal. So towards centripetal, what is the equation? Towards center. Now you find out the force towards center. What is the force towards center? This you can only see one force by the free body diagram. This is T. So this net force T must be equal to mv square by r, and you get your answer for tension. Do we understand this?
Yes, sir.
But wait, there's also one more equation that you can make in the perpendicular direction. What will that equation give you? Here. This is the surface on which circular motion is happening.
It's normal.
Yes, you will get the normal reaction. So perpendicular direction, if I make the equation, if you understand this, that means you understand the concept. If I make the equation in a direction which is perpendicular, the force will be coming from the table. What will be that force? That force will be the normal reaction, and the weight which is going down will be mg. So normal reaction will be equal to mg. It cannot move like this. Do we understand this, or this has gone above what I'm saying? Bye bye, I'm going. Don't worry. Do we understand this, or this has gone above what I'm saying? Bye bye. Huh?
We understood, sir.
If you understand this, then this is a similar question, and I hope that you can get me the answer for this one. A block of mass m moves with a speed v against a smooth, fixed, vertical, circular groove of radius r. So you understand this, now? This is just like a groove like this. You understand this? And a block like this, kept on a smooth horizontal surface. Number one, find the normal reaction of the floor on the block. Normal reaction of wall on the block. We have 2 minutes to do this.
Sir, it's done, sir.
What is the answer that you are getting?
Sir, normal reaction due to force is mg.
Normal reaction due to what is mg?
Floor.
Due to floor is mg. That is the equation in which direction?
Perpendicular direction.
Perpendicular direction. So normal reaction from floor is equal to mg. Well done. What is the normal reaction due to the wall?
Wall is mv square r. mv square by r.
Remember, it is because of this normal reaction which is acting like this that it is moving in a circular path. Do we understand this?
Yes, sir.
Pakka?
Akka, sir.
Well done. Good. If you can do from the first question, if you can do questions on your own, that means you have understood the concept. Then you might not need my help. This is the third question. Now, once you start doing question, you do the dung, 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 dung. So this is the next one. All these questions are JEE Mains plus JEE Advanced. JEE Advanced. The question is like this: a block of mass m is tied to a spring of spring constant. Instead of a string, it's a spring. Natural length is L. The other end of the spring is fixed at O. The block moves in a circular path on a smooth horizontal surface with a constant angular velocity omega. Find the tension in the spring.
Sir, it's hello, sir.
Do we have an answer?
Sir, it's m omega square L, sir.
M omega square L? Huh? How? How it is M omega square L? You have not thought about the question. Tension in the string comes when the string becomes tight, but when does the tension in the spring come? When does the tension in the spring come? When the spring extends or the spring contracts. In this case, will the spring contract or will the spring extend? In this case, will the spring contract or will the spring extend? Imagine there is a block here attached to a spring and I start to move that block. Will the spring contract or will the spring extend?
Neither contracts nor extends.
Then it will not move in the circular path because no one is going to provide it with the centripetal force, beta. If the spring does not contract or does not extend, there will not be any force in the spring and the spring cannot give it the required centripetal force. Do we understand this? So what should happen? The spring should extend. So this is the origin O. It is moving with an angular velocity omega, let us say, and the spring extends by a distance x. So now the total length becomes L plus x. Do we understand this? L was the length of the spring and x is the amount by which it has extended. Do we understand this?
Yes, sir.
Now you can make equation in two direction along the center. Now along the center the spring will try to contract, so it will exert a force. What will be the force in the spring, my dear friends? That will be equal to K into X, where K is the spring constant. Yes or no?
Yes, sir.
That is the net force and that must be equal to M omega square into the radius of the circle. What is the radius of the circle? This L plus X. From there you will get the value of X. Please find out and tell me the value of X. Do we understand what has happened here? When it was a thread, there was no problem. It becomes stout as soon as you start moving the block. But when it is a spring, it has to extend. If it contracts, it will push it outwards. If it push it outwards, it will not move in the circular path. To push it in the circular path, it must move inwards. Do we understand this? Therefore, spring has to extend. Do we understand this?
Yes, sir.
Tell me the value of X.
M omega square L by K minus M omega square.
M omega square L upon K minus M omega square. This is X, but they have asked you the tension in the string. The tension in the string is the force in the string. Force in the string is K into X. So you multiply this thing by K, and that is your answer, my dear friend. Do we understand this?
Yes, sir. We understood.
Girls, I see only two girls here. The rest of the two are missing. No, boys are there. Girls are missing. One half of the girls are missing. Oh, are we there in the class, everyone?
They have health issues, sir.
Okay. Chalo. I hope you have understood this, and whosoever was absent, beta, please give them these notes and just tell them to do these four problems, because in the next class we'll go ahead. So if you, even for you guys, if you don't study what we have done in today's class, the next class will just go above your heads.
Okay, sir.
Please do it before coming to the next class. We have done very simple things, centripetal, tangential and perpendicular, right? So we'll continue with this in the next class. Probably we'll be completing the circular dynamics. We'll also do those questions of work, power, energy, where particle moves in a loop. So that type of questions are left. We will do them probably by tomorrow. We should be able to finish them, so that from the class which starts on Monday, we start with rotation. So that's my target, and hopefully that we can finish rotation by the end of the next week. Let's see if we can do that. Take care. Have a nice day. God bless you all. And I have sent you the sheet. Are you solving the sheets?
Yes,
Everything is
sir.
there in that sheet. Work, power, energy, that looping questions are also there. We'll come to them. Please solve those questions. Okay. Bye bye.
Bye.